each time. So notice the exponent goes 4, we skip to 2, and then nothing. Or we could do 6, and then 4, and then 2, and then nothing. So we want to count by 2s according to the exponent for this particular technique, okay? When it's written that way, we call it quadratic form, and we can factor it by using the diamond. So we want to think about what would multiply to 9 and add to be negative 10, though. 9 and a 1, and they both would have to be negative. Negative 9 multiplied to negative 1 is positive 9. Negative 9 plus a negative 1 is negative 10. So these are going to be our factors. Yep, and this is x to the 4th, so it's not going to just be x, it's going to be x squared. Because x squared times x squared gives you x to the 4th. Now we're going to take each factor and set it to 0 like we did on our warm-up today. And then we solve each one individually. Okay. Now for this one, guys, you could factor this further, but I'm going to use the square root property because I feel like that's probably what you would end up doing. So I'm going to add 9 to both sides. X squared equals 9. How do you undo squaring? Okay. So x is plus and minus 3. Since it was x squared, we got to get 2 answers. And if we take the square root, we get plus and we get minus because positive 3 times positive 3 gives us 9. Negative 3 times negative 3 gives us 9. So there's 2 of them. How many answers are we supposed to get total? 4. How do we know we're supposed to get 4? Right. The degree tells us how many answers we have to get. All right, let's do this other one. All right, you've solved for this one. So if we add 1 to both sides, and then we want to undo the squaring, you're square rooting. All right. So x is plus or minus, what's the square root of 1? 1. So we have 4 answers. If we graph this in our calculator, we'll see it cross the x-axis at 3, negative 3, 1, and a negative 1. That's where the x-intercepts are. Are they real or imaginaries? Real. All of these are real numbers because there's no i's. Okay. All right. Did I lose anybody? What questions do you have so far? Well, we got to be sure that it's set to 0, is it? No. So we got to manipulate it. What is that? All right. So subtract. So we get x to the 4th, x squared. We'll have to do some other technique to solve it. Right. Yeah, we'd have to do some other technique that you don't know about probably yet. Okay. All right, so yeah, we want to check, make sure exponents go down by 2. So we go 4, 2, 0. This one has x to the 0 power on 64. All right, so that means that we can factor it by using the diamond. Okay, so what multiplies to 64 and adds to be negative 12? What is it? Well, we have to add up to get negative 12, though. I hope I... wrote that in. I think it's 16 and what? 16 and negative 4? Well, which one would have to be negative? We want to get negative 12. So the 16 has to be the negative. Remember, we talked about a little bit about the signs. This first sign tells you that the signs will be different. The signs will be different, and this one tells you that the biggest is going to be negative. All right, so we have 4 and negative 16. X to the 4th is x squared. Take each factor and set it to 0. All right, so x squared plus 4 equals 0. We're going to subtract 4. What is it? Plus or minus what? Is it just 2? Why is it an I this time? Okay, because of the negative under the root, yes. So that's where we get I. So these two are imaginary roots. We won't be able to see those graphically. All right, and then if we solve for this one, I'm going to add 16 to both sides of the equals. And take the square root, plus or minus 4. Now, is this one an I? Why isn't it an I, Brendan? There's no negative under the root. Okay, we only get the I's if the negative is under the root. You might want to jot that down in the margin, right? Go ahead and jot that down in the margin on the left. I only get an I if the negative's under the square root. It's a little tidbit to remember. We do have to first make sure that it equals 0. I think that's what you were saying. So what do we have to do? Okay. So we're going to minus 18. All right. So if we want to do the quadratic formula, if we're just not really a factoring fan, we want to identify A, B, and C. So in this problem, well, first of all, do my exponents go down by 2? Yes. Okay. So we could use quadratic formula. What's A, B, and C? And negative 18. So those come from these numbers in front of all the variables. All right. So now we're going to put it in the quadratic formula. But instead of saying x equals, it's actually going to say x squared equals. Okay, it's written on your sheet there. So the opposite of b, so the opposite of 7, plus or minus the square root of b squared. What's b squared? 49 minus 4 times 1 times a negative 18. All over 2 times 1. So 2 times, so over 2. Take a minute to write it down. So we're going to use this just like we would have last month, okay? So I'm going to do just what's in the under the radical first in my calculator without typing the square root button. So x squared equals negative 7 plus or minus. What's all this junk underneath equal? Can you type this part in your calculators? Okay, so you got 121, which is 11. Yes, so let me branch that off. So we get negative 7 plus or minus 11 over 2. let me erase that little part there. Let's just say plus. So I got negative 7 plus 11 over 2, negative 7 minus 11 over 2. But remember, this is what x squared equals. So this is 4 over 2, or 2. This is negative 18. So we actually have x squared equals 2, x squared equals negative 9. And what was this one? 3 plus and minus 3i. Okay? We could have gotten the same thing by factoring. Okay? I think factoring is less work, but if you're not very good at factoring, then you might have to do a little extra. Okay? Yeah. Factoring takes longer? Or? Also keep in mind the problems that we did, all the A's were 1. Okay, so I'm only giving you the ones where A is 1. If A is something else, then you're having to do rainbow, and you probably have to do quadratic formula anyway. So today I'm just giving you ones where A is 1. If A is not 1, then this would probably be easier, the quadratic formula, if that were to pop that. Okay, so the rest of the class period, I'm going to give you time to work on your workbook.